This is going to be an 8th grade lesson for section 1.3. We're going to order real numbers using greater than, less than, equal to, or just putting them in order. So just to get us started, they're going to give us some tricks and whatnot on how to compare and order irrational numbers and how we're going to estimate what an irrational number is. So using perfect squares to estimate square roots, we're going to decide which is bigger, square root of 3 plus 5 or 3 plus the square root of 5. We're going to write less than, greater than, or equal to. So approximate the square root of 3. Well, square root of 3 is in between this perfect square and this perfect square. So it's between 1 and 2, because the square root of 1 is 1, square root of 4 is 2. For the square root of 5, it's in between square root of 4 and square root of 9. Square root of 4 is 2, square root of 9 is 3. So this is about 2.5. This is about 1.5. Use your estimates to simplify the expressions. Square root of 3 plus 5 is in between 1 plus 5 and 2 plus 5. So in between 6 and 7. So it's about 6.5. And then 3 plus the square root of 5 is between 3 plus 2 and 3 plus 3, because that's what we decided the square root of 5 was. So in between, well, 3 plus 2 is 5, 3 plus 3 is 6, so it's about 5.5. So which one's bigger? Well, square root of 3 plus 5 is bigger. All right, so we're going to, for a lot of these, we should be able to just estimate what these irrational numbers are without even using our calculator to decide which one is larger. So let's go to the bottom, and they're going to do number 3 and number 4. Well, number 3, we have the square root of 4, which actually is a perfect square. So over here, this equals 2. So we have 4 on the right side. 2 plus 2 is 4. And on the left, we have 4 plus something else. So no matter what, that's going to be bigger. For number 4, the square root of 12 is in between the square root of 9 and the square root of 16. So that's in between 3 and 4. So it's about 3.5. It doesn't matter which one of those is. Adding 6 is still going to be less than 12. 4 plus 6 is 10. So at best, this is 10. We know it's going to be less than 10, barely. So it's going to be in between 9 and 10. So 12 plus the square root of 6 has to be bigger. Next page. Putting these in order, we're going to do the similar strategy, but we're going to just put things in order instead. So the square root of 5, 2.5, and the square root of 3. Well, let's talk about the square root of 5. That is in between. That's in between the square root of 4 and the square root of 9. The square root of 4 is 3. What? No, it's not. Square root of 4 is 2. I think I was looking at the 9 when I said that. So this is about 2.5. Unfortunately, though, it's going to be, we kind of run into an issue here with the 5. If we say it's 2.5, and we already have a 2.5. So let's figure out what 2.5 times 2.5 is. And let's see if this is bigger or smaller than 5. 5 times 5 is 25. 5 times 2 is 10, 11, 12. Add our 0. We're in the tens place now. 5 times 2 is 10. 4 plus 1 is 5. 5, 2, 6. Move our decimal over 1, 2 times. So 2.5 is actually too big, okay? Which means the square root of 5 is less than 2.5. The square root of 3 is in between the square root of 1 and the square root of 4. So it's in between 2 and, or in between 1 and 2. So as an estimate, we're going to start, this is about 1.5. This is less than 2.5. So 2.5 is going to be our biggest right here. This is our 2.5. Next, we know the square root of 5 is a little bit less than that. So we'll put it maybe about right here. Square root of 5. And then the square root of 3 will be about 1.5. Order them from least to greatest. Square root of 3, square root of 5, 2.5. Number 6, we have pi squared. Well, pi times pi. Let's figure out what 3.14 times 3.14 is. We know that's not perfect because this is an irrational number. It keeps going and going and going and going. But we can use an estimate here. 4 times 4 is 16. 4 times 1 is 4, plus 1 is 5. 3 times 4 is 12. Add a 0 because we're now in the tens place. 4, 1, 3. Add 2 zeros. We're now in the hundreds place. 4 times 3 is 12. 3 times 1 is 3, plus 1 is 4. 3 times 3 is 9. So we have 6, 9, 1, 2, 3, 4, 5, 4, 7, 8, 9. Move our decimal 1, 2, 3, 4 times over 1, 2, 3, 4. All right, so pi squared is about 9.8. Square root of 75 is in between the square root of 81 and the square root of 64. So if this is 8, this is 9. It's about 8.5. So we have 8.5, 9.85, and 10. So this 9.85, we're going to put our pi squared here. 10 is right here. And 8.5 down here is the square root of 75. So least to greatest, we have square root of 75. Let me rewrite that. Oh, whoops. Square root of 75. Then we had our pi squared right here. So this was pi squared. And then we have our 10. Next page. And we'll go to the next page. We'll just knock these out real quick. Some of these might be easier than others. And some of them we might need to do a little more calculations. So let's just go ahead and figure them out. Let me scroll down just a little bit more so we can fit. Well, we'll have to scroll down. So we're doing 1 through 8. Number 1, the square root of 3 plus 2, and the square root of 3 plus 3. Well, that's pretty easy. We know these are the same thing. So one of them's adding 2, one of them's adding 3. Well, the one that adds 3 is bigger. That one wasn't too bad. Number 2, 15 and 15, these are the same. So we're just comparing the square root of 8 and the square root of 11. Well, the square root of 11 is going to be bigger. Number 3, the square root of 6 plus 5. 6 plus the square root of 5. Square root of 6 is in between, it's in between the square root of 4 and the square root of 9. So it's in between 2 and 3. So this is 2.5. This one's also about 2.5. It's a little bit lower than that. But a whole number difference here is going to be enough to show us that the one on the right is bigger. Number 4, we have the square root of 9 plus 3. Well, square root of 9 is 3. 3 plus 3 is 6. On the right side, we already start with 9, so that's bigger. Number 5, square root of 17. That's going to be a little more than 4. Okay, so we'll call that 4.5 minus 3. This is 1.5. The reason this is a little more than 4 is because, well, the square root of 16 is 4. So square root of 17 should be a little bit more. And 4.5 is going to be close enough as an estimate, I'm sure. Negative 2 plus the square root of 5. The square root of 5 is in between the square root of 4 and the square root of 9. So that's about 2.5. So we have negative 2 and 2.5. So this side is negative 0.5. Left side's much bigger. Not negative, it's positive. Left side's still bigger by about a whole. Number 6, we have 10 minus the square root of 8. The square root of 8 is a little bit less than 3 because the square root of 9 is 3. So we'll say 2.8. 10 minus 2.8. Well, 10 minus 2 is 8. And 8 minus 0.8 is 7.2. That's about a good estimate for the left side. 12 minus square root of 2. Square root of 2 is about 1.5. Well, if we're only going to take 1 or 2 away from 12, right side's going to stay bigger. Because 12 minus 1.5 is still 10.5. And that was our right side. Number 7, we have the square root of 7 plus 2, square root of 10 minus 1. Well, square root of 7, that's in between these two again. So we'll say it's about 2.5. And 2.5 plus 2 is about 4.5. On the right side, the square root of 10, that's about 3. A little more than 3, maybe 3.5. But 3.5 minus 1 is 2.5, so the left side's clearly bigger. And the last one here, number 8, square root of 17 plus 3. Well, square root of 17 is about 4.2, because square root of 16 is 4. So add a little bit more to it, go to square root of 17. So this total is about 7.2 on the left. On the right side, we've got square root of 11. That's a little more than the square root of 9. So it's about 4. 3 plus, it's less than 4. It's about 3.5. 3 plus 3.5 is 6.5, so the left side definitely bigger. We had no equals on this. Let me see if I made a mistake. There's no equals. Number 9. We need to put these three things in order from least to greatest. Square root of 3 is between what two numbers? Well, it's between 1 and 2, so it's about 1.5. It's a little less than that, but we're going to go with it. Pi is 3.14, so 2 pi is approximately 6.28, because that's what 3.14 times 2 is. So the square root of 3 is between, I guess we have a 1.5, so let's see if it needs to be bigger or smaller. 1.5. 1.5 times 1.5, 5 times 5 is 25. 5 plus 2 is 7. Add our 0 down the tens place. 5 times 1 is 5. 1 times 1 is 1. This is 5. 12. 2.25. Ooh, so we got to be bigger than that. So it's actually bigger than 1.5. Because that's not, 1.5 times 1.5 didn't get us to 3. So it's going to be a little bit greater than 1.5. So let's start with 1.5 on our number line. We'll have a number a little bit greater than 1.5, which is the square root of 3. And then we'll have our 6.28 way out here. This is our 2 pi. So least to greatest is 1.5 square root of 3, 2 pi. And number 10, 4 people here have methods to solve for the perimeter here of a forest, and the results are given in the table here. Leon, Mika, Jason, Ashley. So Ashley's is given here in a decimal. It's 2.5. Next, we need to figure out what Leon's is going to be. This is about a little more than 4. It's a little more than the square root of 16, so let's say 4.2 minus 2. So for Leon, what do we have? 2.2. Pi over 2, well, let's estimate what 3.14 divided by 2 is. Well, and I said estimate because I want to estimate this. Half of 3 is 1.5. Half of 0.14 is 0.07. So it's going to be 1 plus this, because the 1 needs to come up with it. So we have about 2.57 for Mika. We got 2.5 for Ashley. And let's change Jason's to a decimal. 12 divided by 5. 12 divided by 5. 5's in 1. Nope. 5's in 12. 2. 10. 2. Not done. Bring down to 0. 2.4. So we've converted these two decimals. The results are given, and we need to order them from greatest to least. So the biggest one we have here is Mika, which is 1 plus pi over 2. Next will be Ashley's, which is 2.5. Next will be Jason's, which is 12 over 5. And last will be Leon, which is square root of 17 minus 2. Number 11, explain how to order a set of real numbers. We need to convert to decimals and approximate irrational numbers to put them in order. Now, when you get to your homework for this section, I'm anticipating that a lot of you will be checking your work a lot with a calculator. I'm okay with that. If you don't want to show your work for 12 divided by 5, you just want to show 12 divided by 5 instead of doing that and do it on a calculator instead, I don't have a problem with that. If you want to do the square root of 17 on your calculator and then do minus 2, I don't have a problem with that. Okay? So that's my expectation is you just, we have strategies, we have skills to put these numbers in order. We just need to figure out what they equal in decimal form and then just make sure you're putting them in the correct order. Be careful. The number 2.2, the number 2.4, remember if you're going to compare with the hundreds place, remember there is a 0 after these numbers. So this is 20, 40, 50, 57 from least to greatest. It wasn't just 2 and 57. It's 20 here. So remember when you're putting these in decimal form, just make sure we're lining up our decimal for comparisons and adding the same amount of zeros so that they all have the same place value. And I don't think we'll have any misunderstandings after that. So let me know if you need any help.